So for number 6, you have to identify the roots. It says state the multiplicity, draw the graph. So you should be going to the graph first for these, drawing the sketch of the graph, and then notice at 4 there's a touchback. So there's an even multiplicity here. Because the degree is 3, there are 3 total zeros. So this counts for 2, this counts for 1. So it's negative 6 and 4 has a multiplicity of 2. Okay? If it's a multiplicity of 1, you don't have to tell me that. And then for b, it's x cubed. There is a bend in the graph. And then you have 1/2. Now, with the 1/2, that's kind of hard to see on the graph. So what could you do to find that it was 1/2? There's a couple different ways. Yeah, plug in the equation and then you can use the 0 function, right? So if you have 8x cubed minus 12x squared plus 6x minus 1, you can graph it. And then from there, there's the 0 function. So you can go to second calc and you can do the 0 this way. It's going to ask you the left bound. So if the 0 is on the x-intercept, just go a couple to the left. I think even here is fine. And then go a couple to the right. So get above the axis and then try to get right on the axis. Okay, and that's going to round up to 0.5. So it's 1/2 of the multiplicity of 3 because there are 3 zeros. Okay. All right, and then for number 7, it says solve the polynomial equation using factoring. So when you are factoring, you have to factor the polynomial completely. Okay? This is where sometimes people lose a point because they don't factor it completely. So remember, here are your rules. If there's anything in common, you can take it out, but also look for special patterns because if you have 4 terms, you have to factor by grouping. So we're going to group the first 2 together, group the second 2 together. We're going to take out the x squared, which leaves us with 2x plus 3. We're going to take out the negative 4, which is 2x plus 3. You cannot factor by grouping if these are not the same. So if they're not, you either need to double check that you took out the GCF, or you got to find another method. Okay? I'm not going to tell you to solve something by factoring that's not factorable. Okay? So then this is x squared minus 4. What do you have to remember about this? What is x squared minus 4? Yep. Do you guys remember what that pattern is called? Yeah, difference of 2 squares. So you just have to factor it down. Okay, so on your test, if you didn't factor it down to this point, then I would take off a point. But you could still get all the right answers from there. Okay, but if it says factor, okay, you have to factor completely. If it doesn't say that you have to use factoring, then you could set this equal to 0 and solve. It's just if it says factoring, as you see, you can factor it all the way down. Okay? All right, number 8. List all of the steps for finding the roots of an equation. So the first thing you do is you find the possible roots. That helps you so when you go to step 2 and you're finding the x-intercepts on the graph, you know what you're looking for. And then you are going to verify that with synthetic division. And then when you verify the roots with synthetic division, you have to keep going until you get to a quadratic. Remember, you want to make sure the remainder is 0 to verify the root. And then once you get a quadratic, you're going to solve it. Most of the time, you've been solving with a quadratic equation, but there are some where when you set it equal to 0, it'll just be 2 terms, and it'll be easy to just solve the equation.
For number 7, why would it be x minus 2 and x plus 2?
So the x squared plus 4, that's one of your special patterns, so you can factor that down again. So that pattern is the difference of 2 squares. So when you're factoring, right, you have to get it down so that there's no special patterns, no GCF. So for x squared minus 4, it's x and x. And then what multiplies to negative 4 but cancels out? A positive 2 and a negative 2. And if you were to FOIL that back, that you would get the x squared minus 4. Yes. And again, the only reason why you have to go all the way down is because it says to do it by factoring. Okay, and then after you use the quadratic, so once you solve the quadratic equation, just identify your zeros. That's your last step, okay? All right, and then we're finding all the roots for number 9. We are going to do the first ones of those together. So we're going to follow those 5 steps. Okay, so for number 9, do we see any more time with this one, this time? The steps? Well, we are going to do the steps. Okay, so for the first one, we are going to do our P over Q. Okay, so the first step, P over Q, factors of the constant over factors of, the leading coefficient, the 1 and the 2. Okay, and then what you're going to do is you're going to divide. So 1 over 1, 2 over 1, 4 over 1, 8 over 1. Then you divide by 2, plus or minus 1 over 2. 2 over 2 is 1, 4 over 2 is 2, 8 over 2 is 4. Okay, so you don't have to repeat those. So now in step 2, when you're looking for the x-intercept, you are looking for these. Okay, if it's not on that list, you're not going to find it on you're not going to find those rational zeros on the graph. Okay, so you have 2x to the 4th plus 5x cubed minus 10x squared plus 10x plus 8, and then you graph. Now, you can also, if you're not sure like what's happening there, where's the place you can go to verify? Yeah, you can go to the table. What do you look for in the table? Zeros in the y. And then look, at -4, yep, there's a 0. The other one looks like what? Well, if I'm looking at my list, I can see this is in between them. So to me, that looks like -1/2. Do you want to know how you can verify that with your table really quickly? You can go to your table set, second table set. Instead of starting at a whole number, just start at -0.5. And then if you get, -0.5, there you go. And then if you check your table now, it'll tell you it's a 0. Okay, and then you can just go back to table set, just put it back to a whole number, and then you'll be good. Okay? All right, now, this is x to the 4th. How many times did you guys have to do synthetic substitution for this? Yeah. If it's x to the 4th, you are going to have to do it twice unless you decide to factor when you get a cubic. Okay? And then it doesn't matter which one of these you do first. Okay, so this was a 2, so I started with -1/2 because I knew it was going to divide evenly to -1. This would be -2, -12. -12 divided by -2 is 6. 16, -8. Yay! So if you want, you could try to factor the cubic. Okay, but because you have 2 intercepts, remember you can do the double synthetic. -4. Bring the 2 down, so this would be -8, -4, 16, 4, -16, yay! So then you get the number, the x, and the x squared. Okay, and then once you get here, you're going to do the quadratic formula. If you want, you could divide this all by what? You divide it all by 2 and work with smaller numbers. How many of you did that? Divided it by 2? Okay, so most of you didn't, so I will use the A is 2, B is -4. You'll get the same answer. It's just this way you have to simplify. If you do not know what the quadratic formula is, that's something I'd write on my note card. It's the opposite of B, plus or minus B squared, minus 4AC. Yeah, divided by 2A. So 4 times 2 is 8. 8 times 4 is 32. What's 16 minus 32? Okay. So if you look at this square root, what's the square root of 16? Just regular 16. 4. So the square root of -16 is 4i. So this is 4 plus or minus 4i. You have to divide each of these by 4. So it's 1 plus or minus I. So now I can round up all my zeros. I know that there should be 4 because that is the degree of the polynomial. So you are going to have negative 1/2, negative 4, and then if you want to write those together, that's fine. Just know that those count as 2. 1 plus I, and then 1 minus I. Okay? All right, now for B, you have x to the 3rd. So how many times are we going to have to do synthetic division for that? Just 1 time, okay? So for that one, you can do your P over Q, and because the leading coefficient is 1, you know that you're only going to have these whole numbers. Okay, plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. And then we're going to go to the graph, find the x-intercept. There's only one x-intercept this time. What is it? Yep. Okay, so again, you find that from the graph, and then we can verify with synthetic division. So you can do synthetic division, 0, 0. All right, now, once you get here, this is a quadratic because you have the number, the x squared. X squared minus 5 equals 0. You could do the quadratic equation, but do you have to? Nope. This is where you can solve because you just have a constant and x squared, which means if you get the number on the other side, you can take the square root. X equals plus or minus root 5. Just don't forget your plus or minus, okay? So then your zeros are negative 3 and plus or minus root 5. Okay, questions for me on that one? Okay, let's look at the other two. On the back.